Part 4. Cloud IAM. IAM systems embedded in cloud services to manage identity, roles, and entitlements natively in the cloud environment. Cloud IAM stands for Cloud Identity and Access Management. It's a system that helps organizations control who can access what in a cloud platform like AWS, Microsoft Azure, or Google Cloud. It ensures that the right people or systems have the right access to cloud resources like servers, storage, database, and apps at the right time. Real life analogy? Well, imagine a digital key system in a smart building. Cloud IAM act as the central system that controls who gets which key to open which door and when. What Cloud IAM does? Well, it authenticates, that is, verify who the user or system is. They authorize, decide what the user can access or do. They perform role management, assigning users to roles, whether it's admin or viewer. They have policy enforcement, wherein they apply access rules, and logging and auditing function, which is tracking who did what and when. Example: AWS, Azure, Google Cloud. The benefits of a cloud IAM. Well, central control over access to cloud services. It provides better security through MFA, least privilege, and has clear audit trails. Its fast provisioning and deprovisioning of access is a big winner. It has easier in compliances with security policies and regulation, hence easier implementation and helps during this phase. It's scalable to support thousands of users and services. Example: a cloud admin in AWS uses Cloud IAM to allow a developer to access only one S3 bucket, or set up MFA for all users, or create a log of every time someone modifies the infrastructure. Comparison to traditional IAM and Cloud IAM. Cloud IAM is cloud based deployment environment. The scope for Cloud IAM is cloud resources, SaaS apps, hybrid environments. It's highly scalable, elastic, dynamic user growth supports that. Its access control method are RBAC, ABAC, and policy access control or PBAC. It's integrated with cloud app APIs and services. Management interface is web based, it has a dashboard, and API automation is inbuilt. It enforces globally via cloud native policies when it comes to policy enforcement. From maintenance perspective, it's managed by the cloud provider, the shared responsibility. From an auditing and login perspective, it is centralized cloud based audit trails and alerts. Typically used in modern enterprise, startups, cloud native, and hybrid IT environment. That's the cloud IAM. From a traditional IAM perspective, it is used in banking, healthcare, and regulated industry with legacy infrastructure. Common challenges in IAM? Well, too many privileges granted, violates least privileges, requires close integration with HR, DevOps, and security tools. It's complex policies if not well structured. Now, do note, this is not cloud, this is overall common challenges. The other challenge is misconfigured permission can lead to data leaks. That's a major challenge that we know about. Now let's look at the context when it comes to the other aspects of IAMs. Before that, let's look at something else, which is native identity, roles, entitlements in cloud environment. So what are native identities, roles and entitlements in cloud environment? Well, in cloud platform like AWS, Azure or Google Cloud, native means the built-in identity and access features, the built-in that comes directly from the cloud provider, not from an external systems like Active Directory or Okta. These native elements are identity, who or what is accessing the cloud, roles, which is what levels of access the identity is given, entitlement, what specific action or permissions are allowed. In detail, native identity. Well, these are user accounts or service account that are created directly inside the cloud platform. That's native identity. Native to the cloud. Example, a developer account to log in into AWS console. That's a AWS IAM user. Or a built-in user account in Microsoft Entra ID, which is part of the Azure AD. Or an identity used by an app or virtual machine in Google Cloud IAM service. From a use case perspective, a data analyst logs into AWS using a native IAM user to access the S3 data bucket. Now, roles. Well, native roles. Roles define what an identity is allowed to do. A role groups permission together like read only or admin. Example, Amazon E3 read only access reads only access to EC services, EC2 services. That's in AWS. When it comes to Azure, it's contributor, that is full access to manage resources but not assign roles. From a Google perspective, role, storage objective, view only access to Google Storage Cloud. That's a role. From a use case perspective, a DevOps engineer is assigned the compute admin role in GCP, allowing them to manage VMs but not delete billing accounts. So do note, the first one was identity. It's about user account and service that comes inside. The next is roles, what they are allowed to do. And the third aspect is entitlements. Now, what's entitlement? Entitlements are the specific action or resource level permissions assigned to an identity or role. It is what are they entitled for. Think of them as a fine grained permission. Example, in AWS, it's a permission to download files from a bucket. In Azure, start a VM. In Google, it is view project metadata. These are examples. From a use case perspective, a machine learning model runs on GCP has an entitlement that it allows it to read data from BigQuery but not delete it. In summary, identity, it represents who or what is accessing the cloud. Your identity. Who are you? What are you trying to do? Use case, developer logging into a cloud. Role, you are the one, but what is that you can access? The group that you are part of. Example, assigning limited access to a team. Entitlement, what specific permissions you are having. That is, you can download a file but not edit it. So that's in summary. Now, why does this matter? Well, understanding native identities, roles, and entitlement is crucial for applying least privilege access, configuring fine grained security controls, or enabling compliance with cloud regulations, and supporting zero trust and just in time access. Now let's compare native identity, federated identity, and RBAC in cloud. Pretty complex? No, it's actually very clear demarcation. Native identity we mentioned within the cloud, it is identity created. Federated is external user authenticated via trust identity. RBAC in cloud is role based access based on user assigned roles. Where identities are managed? In native, it is inside. In federated, it is outside. In RBAC, is assigned via native or federated identity. How the access is granted? In via native roles when it comes to native. Federated, it is mapped to users to roles and it's on policy and trust configuration. In RBAC, it is predefined roles and bundled permission. Examples native is AWS, Azure AD, GCP service account. When it comes to federated is SSO. When it comes to RBAC, same with built-in role like readers and contributors. When it comes to scalability, well, native is good for small and medium. Federated is highly scalable. RBAC is well scalable in groups and organizational units. From a security consideration perspective, must secure within the cloud, no external identity validation. Federated requires a strong trust and token based security. In RBAC, role must be audited to avoid over permission. Native is best suited for quick setups, isolated projects. Federated when it comes to collaboration on large enterprise with central identity provider. RBAC is day-to-day access management with clear responsibility and boundaries. Native is self-contained within the cloud. Federated, it relies on IDPs, identity providers. Whereas RBAC, it depends on properly defined roles and policies. Zero trust. It's about align with zero trust principle, emphasizing continuous verification of users and adaptive access decision based on context and risk. What does it mean? Well, zero trust IAM is an identity and access management strategy that follows the principle never trust, always verify, no matter where the user or device is coming from. That is, instead of assuming that users inside a corporate network are safe, Zero Trust IAM verifies everyone, every time, and under every conditions before allowing access. Real life analogy, imagine a high security office building. Even if you are an employee, you must show your badge, scan your fingerprint, and confirm your destination every time you enter a new room, not just when you enter the building. That's zero trust IAM in action. Core principle of zero trust IAM: verify explicitly. That is, always confirm identity and access right before allowing entry. And that is at each step. It has a least privilege access. User gets only the access they need and nothing more. They assume breach. They operate as if attacker might already be inside the networks and requires continuous validation. The access decisions are made in real time and rechecked constantly. And they are context aware decisions. Access is based on multiple factors, which includes identity, device, location, and risk levels. Let's look at the key features of Zero Trust IAM. First, multi factor authentication, which is verifies identity using multiple methods. The password, OTP, device check, etc. It has adaptive access control. It is access is dynamically adjusted based on the context. Example, block logins from unknown location. Example. Just in time access. Access is granted only when needed and for a limited time. It has micro segmentation. Access to resources limited. Even within the system, users don't get full access. Identity Federation and SSO. It ensures secure, unified identity across cloud, on prem, and third party systems. And every login, access request, or session is logged and analyzed as part of its continuous monitoring. So, how does it work? Well, user requests access. IAM system checks, identify the user ID and the device trust, its roles and permissions, its location, device health, login time, threat level or behavioral risk. It checks and then system grants or denies access dynamically. If it is allowed, the session is monitored continuously and the action is revoked immediately if something suspicious is detected. So that's the flaw. The benefits of zero trust: strong security. There is no implicit trust, minimizes insider and external threats, reduces attack surface by limiting exposure with least privileges and segmentation. It has better compliance, it supports GDPR and so on. It has faster breach detection, which is continuously monitors, flags unusual behavior immediately. And it is cloud and remote ready, ideal for hybrid and work from anywhere environment. Challenges: it has a very complex implementation, requires orchestration of multiple tools and systems. User friction: too many checks can frustrate users if not designed well. Tool overload: we need integration of identity, network, and endpoint tools. Cultural shift: moves away from the traditional trust based network model. Zero trust IAM checks her roles and verifies she only needs read only access. Ends her session if she leaves it idle or if abnormal behavior is detected. Blocks access if she tries to download from an unfamiliar location. Validates her identity with password, OTP, and known devices. This is a case when a financial analyst logs in from home to access cloud report. So basically, it checks, validates at every step, and at a slightest of deviation or suspicion, it triggers off disconnection. Difference between traditional IAM and zero trust: from a trust model perspective, zero trust, it's no trust by default and always verify. From authentication perspective, it's continuous and contextual. From an access rights perspective, it's based on roles, context, and risk. From an enforcement perspective, it's real time and dynamic. From a network assumption, every location is treated as a potential risk. Very different from the traditional IAM. Let's try to look at the flow. First, it defines the vision and secure stakeholder support. How do we get this in an organization? First, you need to define the vision and secure stakeholder support, without which you can't move forward. You need a sponsor, a senior sponsor. Clarifies the zero trust principle, which is about never trust, always verify. Aligns with business goals, security, compliance, cloud readiness. Secure executive sponsorship from IT, security, and compliance leader, that is across the board, across all the layers of the organization. Once done, then assess the current identity structure. Once as part of that, inventory all user identities, employee, vendor, partner, service accounts, etc. Map the current IAM tool, whether it is AD, Azure, Okta, etc. Review the current access provisioning and deprovisioning, MFA and SSO process. Identify high risk areas, legacy systems, over permissions users, orphan accounts. Then establish identity as the new security perimeter. Consolidate identity sources. Have a unified HRM, AD, or Entra ID. Ensure identity federation for external user or multi org environment. Centralized authentication through a trusted identity provider. Once we achieve it, we move forward. We implement a strong authentication, which is MFA everywhere. Then enforce multi-factor authentication across all your user type. Prioritize privileged user and remote access first. Then choose adaptive MFA, push, biometric, risk based. Once you achieve, we move to the next step of adopting least privilege and role based access control. Then we go and define business roles and map access requirements. Enforce just enough access through RBAC or ABAC. Then remove excessive or dormant entitlements. Automate provisioning and deprovisioning via HRMS and IAMS systems. Then we move to step 6, which is enforce conditional and context aware access policy. Use conditional access based on device trust, location, the time of the day, risk score or UEBA, on block or challenge unusual access attempt in real time. Once we reach this, we move to step 7, which is enable continuous monitoring and risk based access decisions. Integrate SIEM, SOAR or identity threat detection tool. Monitor login behaviors, device postures, and access parameters. Patterns. Automatically trigger re authentication or session revocation upon anomalies. Then we move to step 8, which is securing non human identity. Example APIs, bots, service accounts. Catalog machine identity and service accounts. Then we apply least privilege and hold the credentials or secrets. Monitor usage and apply the same zero trust principle. Then we move to step 9, which is automate access reviews and certifications. Schedule periodic access reviews by role, department, or application. Use IAM tools to enable self service and manager approval. Track completion and remediation for compliance audit. Then we move to the last step, step 10, which is establishing governance, documentation, and training. Define clear policies. Define MFA, break glass access, entitlement requests, etc. Then provide awareness training to users on zero trust principles and document the entire process and maintain audit. So, this is a step to step roadmap for implementing zero trust in any organization. Based on your organization and the complexity, you might have few more steps or additional details to be added, but this gives you a top view. The request is to pause the screen at the 4 slides, providing the 10 steps in detail. Check against yours and see which part you are already covered. If you already implemented, check against this and see is there anything that would have been missed. You can add on to it. I hope this step by step approach helps you in your strategy. Adaptive access decisions. What are these? Adaptive access decisions are dynamic access rules that change based on the current context and risk levels of a login or activity request. Instead of using static yes or no rules, the system analyzes multiple factors in real time before deciding to allow access or block access or ask for extra verification like MFA or grant limited or read only access. The idea is access isn't one size fit all. It adapts based on what's happening. So that's adapting to the access decisions with what's happening around. Now, what does context and risk mean in zero trust? Well, context is who is trying to access, the user, role, identity, what, that is what resources are being accessed, what time of is the access requested for, working hours or not, what location the login request has come from, what are the device types that is requested, whether it's a corporate or unknown phone, is the activity normal for this user, has this IP or device been flagged as risky. So this is how the system evaluates before making a access decisions. Example, scenario 1. User is a finance analyst, device is a trusted laptop, location is a Mumbai location, example, time is 11 a.m. This looks like a safe access. Hence, access is granted silently without extra prompts. Second scenario, same user uses a new device outside India. Time is 2 a.m. Access is blocked or requires MFA plus approval. This is an unusual access. The third is a case of elevated access. Developer tries to access production environment. High risk operation. Example, data delete, database delete. The system triggers approval workflow and logs the activities. You remember, it's not complete. You have triggered a new workflow, but in parallel, it also logs the activity. So, how adaptive access decisions work technically? Well, user attempts login to or access. The IAM or CSB systems evaluates identity trust levels. Then device checks device trust score, checks for IP address, geolocations, time and behavioral anomalies. Then it goes into decision engine, wherein conditional access in Entra, Okta, or Ping, checks for predefined policies, uses machine learning for user and entity behavior analytics, and grants system access or denies or challenges the access. So this is how an adaptive access decisions work in the backend. Benefit of adaptive access: it improves security by blocking risky access automatically, gives better user experience. User aren't forced to use MFA every time. It's context aware protection. It adjusts control based on real situations. It supports zero trust, which is always verify even if it is inside the networks. Microsoft Entra conditional access. These are some of the access methods. Example tools that support adaptive access or Okta, Ping One Risk Engine, or Cisco Due Risk Based Authentication, or Google Beyond Corp Enterprise. Some of the tools that support adaptive access. You might have used it already, or if you are planning to, these are your options. Some of the options. There are many more which would be there in the market. Check out the comfort level that you have against each, or the one which you think works for you best. Some of the leading IAM platforms: Microsoft Entra, Okta, Ping Identity, IBM Security Verify, SailPoint for identity governance, or CyberArk for privilege access management. Now let's look at individual. Microsoft Entra ID. Microsoft Entra ID is Microsoft's cloud-based identity and access management service. It was formerly known as Azure Active Directory until its rebranding under the Microsoft Entra product family. It helps organizations securely manage who can access the resources, what they can access, how they authenticate, where and when they access from. Think of Entra ID as a digital gatekeeper for your cloud and on premise resource. It verifies the identity of users and decides whether to let them in, ask for more proof, or deny access based on rules, roles, and risk. Core function of Microsoft Entra ID. It validates users' identity with password, MFA, biometrics, or passwordless method. It has one login, gives access to multiple apps. It organizes users into department, role, and assign access rights in bulk. It grants or blocks access based on location, device, user risk, or behavior. It adds a second layer of protection to reduce password based attacks. It detects risky sign ins and blocks or challenges them automatically. It lets partner and customer use their own login credentials. It regularly checks if user still needs the access they have. It has time bound and just in time access to sensitive resources. It's natively compatible for unified identity management. Now, what can you protect with Entra ID? Well, cloud apps like Microsoft 365, Salesforce, ServiceNow, Dropbox, etc. On-prem system, which includes services taken from LDAP, legacy AD integration. Device, Windows, Mac OS, mobile devices. Infrastructure, Azure resources, VM, storage, Kubernetes, or external users with the partner access or customer portal. So it has a wide use when it comes to protection. Key benefits: it manages all users, internal and external, in one place. It enforces continuous verification and manages through least privileges. It's high availability because of cloud native with global redundancy. It helps meet any standards, namely ISO 27001, GDPR, DPDP. It user access apps securely. User access apps securely without multiple logins. It's a seamless experience. Use case: a bank may use Microsoft Entra ID to let employee access Microsoft 365 and SAP using their work credentials. Requires MFA if users sign in from a new country. It lets contractors log in using their own company credentials. It automatically removes access when someone leaves the organization. Common challenges associated? Well, complex for beginners. It requires careful policy and role design. Some advanced features require premium P1, P2 licenses. Yes. Integration with legacy AD, syncing with on-prem AD can require is Azure AD Connect. Well, it needs proper risk-based policy to avoid over-prompting. So you might have an MFA fatigue or bypass. In summary, Microsoft Entra ID does authenticate users using modern method, manages who can access what, when, and how, adapts to user behavior and threat levels, supports auditing, reviews, and conditional accesses, seamlessly integrate with Microsoft ecosystem. Let's now look at Okta. Okta is a leading cloud based identity and access management platform that helps organizations securely manage who can access application and systems, or how user signs in and gets verified, or what level of access they are granted. Okta enables single sign on, multi factor authentication, user provisioning, and lifecycle management, all from the cloud. Think of Okta as a digital security gatekeeper that sits between your user and the system they need to access, ensuring that the right people get the right access at the right time. Core component of Okta: it allows users to log in once and access multiple apps. It adds another layer of protection through OTP, push, biometrics. It's a centralized place to store and manage identity attributes from different sources, whether it's HR, LDAP, or AD. It automates onboarding, offboarding, and access changes. It protects API using Auth 2.0 and other standards. It manages internal and external users, whether it's employee, contractor, partners, and customers seamlessly. For example, an employee logs into the laptop, Okta verifies their identity with SSO and MFA, and the user is granted access to Microsoft 365, Salesforce, Zoom, and HR systems automatically. They need not have to do anything again. So, how it works? Well, users sign in to Okta using browser, mobile app, or VPN. Okta checks the user's credential and applies the MFA. Based on the policy defined by you, Okta allows or blocks the access. Then Okta provisions or updates user access in connected apps via API. And all activities are logged and auditable. Okta integrates out of the box with Microsoft 365, Google Workspace, Salesforce, SAP, Workday, AWS, GCP, Azure, Zoom Service Now, Box, GitHubs, custom apps via SAML, OAuth, and OIDC. So it has a wide out of the box integration or engagement, seamless. From a IAM capability support perspective, it supports username, password, MFA, biometrics, and passwordless. From an authorization perspective, it has role based, group based, attributes based access policies. From a provision perspective, it can auto create, update, deactivate user across systems. From a governance perspective, is integration with access reviews and compliance checks. From a zero trust perspective, it has conditional access, device trust, and adaptive MFA. From a federation perspective, it provides functionality for SAML, OIDC, OAuth, or cross org or external identity provider. From benefit perspective, there is no need to manage on-prem servers. It's cloud native, suitable for small teams to global enterprise, highly scalable. It works with Microsoft, Google, AWS, and others, so vendor neutral. Has strong security. You can use work on the MFA, contextual access, real-time threat detection, and has an excellent user experience through simplified login and centralized access to apps. Challenges or consideration. Cost. It may be expensive for small teams or startups. It requires planning, especially for large orgs with many apps. Some capabilities may duplicate those in Microsoft Entra ID if used together. It requires user training and IT alignment for full adoption. When to use Okta? Well, an organization with multiple cloud apps and no single identity source, or companies needing strong zero trust access control, or enterprise managing external user account, whether it's partners or customers, or businesses moving from on-prem IAM to cloud-first identity, or teams that want identity federation and central access management. All of these are right cases to use Okta. Ping identity. What is ping identity? Well, Ping Identity is a cloud ready identity and access management platform that helps enterprise manage and secure digital identity for both internal users, which is employees, and external users, partners, or customers. It enables secure authentication, single sign ons, multi factor authentication, user provisioning, access control policies, identity federation. Ping identity is often used by large security focused organizations with complex hybrid IT environments, whether it's on prem or cloud mixture. Think of Ping identity as a unified login and security gateway that ensures only the right user can access the right application using the right method from the right place at the right time. Key products in Ping Identity Platform. Ping 1, which is Cloud Identity Platform, SSO, MFA, User Directory. Federated Authentication and Identity Federation Server. Ping ID, it's about adaptive multi-factor authentication. Ping Directory, it's high performance directory for identity storage. Ping Authorize, it's fine grained authorization using policies. Ping Central, it's centralized control for app integration and configurations. Core capabilities? Well, user logs in once and access all applications, cloud or on-prem. Additional verification like OTP, biometric, post notifications are part of this. It enables users from other trusted domains to log in using their own credentials, using SML or OIDC. It syncs with LDAP, Active Directories, and Cloud Directories. Controls and secure API access using OAuth and fine-grained policies. It's decision based on risk score, device location, time, and behavior. It secures login and experience for B2C and B2B customers. Where ping identity is commonly used? Well, they are used in enterprise with hybrid infrastructure, cloud as well as on prem, when it is both. They are used where businesses with B2B and B2C identities are needed. Used where organization requires strong security and requires customization. They are used in industries like finance, healthcare, government, where policy enforcement is critical. Example, a global bank using ping identity to let employee log in into internal and cloud app using SSO, requiring MFA for high risk logins, example unknown devices, or allow partner firms to access shared apps via SAML federation, or store all identity in ping directory with high availability. This is a case study. Benefit of ping identity? Well, it is designed for large regulated environments, adaptable for complex identity needs, works across cloud, on-prem and legacy apps, available as SaaS, on-premise or hybrid, supports SAML, OAuth 2, OpenID Connect, SCIM or FIDO 2. Challenges? Well, requires skilled resources to deploy and manage for sure. Compared to lightweight IAM protocol, it has an initial higher startup time. It may be costly for smaller organization. Needs planning for legacy and custom applications. We need some integration overheads. In comparison, Ping Identity deployment is on-prem, cloud or hybrid, whereas Okta and Entra are cloud native. Ping Identity is highly customizable. Okta is simpler but more standardized. It's best fit for complex high security environment, whereas Okta cloud first and SaaS driven organization. Let's now look at IBM Security Verify. What's this? IBM Security Verify is IBM's cloud native identity and access management platform, designed to help organizations secure user identity, manage access, and enable zero trust across hybrid and multi cloud environments. It offers a full suite of IAM capabilities for both workforce and customer identities. Think of IBM Security Verify as a smart IAM system that combines traditional access control with AI driven threat detection and adaptive access decisions. This to help protect people, data, and application. Now we are looking at IBM security as Few organizations might be aligned to this. Hence, thought of touch basing this aspect. Now, what does IBM Security Verify do? Well, it's a one login, gives user access to multiple apps, adds another layer to identify verification using MFA. It grants or blocks access based on roles, rules, and risk levels. It ensures access is appropriate and compliant through reviews and certifications. It automates provisioning and deprovisionings of users, uses context like location, device, behavior to adjust access decisions, identifies risk logins and access behavior using machine learning. It's a central place to manage identity across hybrid environments, manages identity across apps using SAML, OIDC, OAuth, and SCIM. How IBM Security verifies fit into IAM? Well, authentication, it uses SSO, MFA, passwordless biometrics. It supports. It supports role and policy based access, whether it is RBAC or PBAC. It supports just in time provisioning and automated onboarding and offboarding. It supports access reviews, entitlement certificates. It supports trust based login using external IDPs, which is identifying, which is Entra ID or Okta. It supports behavior analytics and login anomaly detection. Use case: an employee signs in into IBM Verify with SSO. The system checks if it's their usual device and location. If yes, access is granted. If the login appears risky, whether it's new country or time, MFA is triggered or access is blocked, and admins get notified and can investigate via dashboards. In comparison, there are IBM Security Verify and IBM Verify Governance. Security Verify is cloud native. Verify Governance is on-prem governance for provisioning, review, compliance, etc. The benefit of IBM Security Verify: it enforces continuous verification and also has least privilege options. Uses machine learning to detect and respond to identity threats. Works with AWS, Azure, GCP, and on prem apps. Ensures compliance through access certifications. Connects with thousands of apps and enterprise systems. Challenges? Yes, it needs planning for large environments. Some advanced features are premium only. May require integration knowledge across cloud and legacy IAM tools. Some capabilities may overlap with other IAM and SIEM platforms. Common integration works well with Microsoft 365, Workday, SAP, ServiceNow, Salesforce, and a whole lot of things that. So basically, it has a good integration capabilities. In summary, it has strong authentication, SSO, and adaptive access. It works seamlessly, secure customers, login experience. From governance, it has good access reviews, role cleanup options, and audit readiness. It has AI powered risk detection and policy automation. It is fully cloud native and with on prem governance add on. Now let's look at how zero trust implementation is done through IBM Security Verify. It defines, first you have to define your zero trust strategy. Then you identify high value assets. Then map user identities and device that access them. Align the roadmap with compliance goals. Appoint a zero trust steering committee. Then you move to step 2, which is deploy IBM Security Verify as your core IAM platform. Then you enable cloud native IAM to support hybrid environments. Then integrate HRMS, AD, LDAP as the source of identity truth. Start with single sign-on across key SaaS and enterprise app, and then use IBM Verify directory or federates with existing IDPs. Then step 3 is enforce strong authentication across users. Roll out MFA using IBM Verify app. Apply MFA to all user, workforce, partners and customers. Use biometrics, OTPs, push notification and passwordless options. Prioritize privileged user and remote access endpoints. Then we reach step 4. Step 4 is enable the context aware and adaptive access control. Use IBM Verify Risk Engine to assess device posture, assess login behavior, assess location and time, and create an adaptive access policy. And then we integrate with IBM QRadar or other SIEM tools for threat correlation. Once done, we reach step 5, that is applying least privilege and fine grained authorization. Design and enforce role based access control. Implement just in time access for sensitive operations. Leverage ping authorize or IBM verify authorization to manage contextual, policy driven access. Automate access provision using HR triggers. Once done, we reach step 6. Step 6, we secure the APIs and application access. Then protect APIs using OAuth 2.0, OIDC through IBM Verify API gateways capabilities. Then define scope, tokens and consent for each app API access. Then monitor API traffic for anomalies via integrated threat engines. Once we do that, we reach step 7. Implement continuous monitoring and risk scoring. Activate AI powered insight to detect suspicious pattern. Set up real time alert sessions, terminations or step up authentication. Then log all authentication and access event for forensic analysis. Use dashboard analytics to measure zero trust maturity and compliance. Once done, we reach step 8, wherein we launch governance and access certification program and schedule access review for roles, apps and entitlements. Engage managers and application owners in attestation workflows. Clean up unused roles or excessive entitlements. Then we reach automate the evidence collection for audit readiness. Once done, we reach step 9, wherein we expand to B2B and customer IAM or CIAM, extend identity federation to partners and suppliers, enable secure user friendly CIAM experience using IBM Secure Verify for CIAM, apply branding, self registration, and consent management features. Once done, we reach the last step 10, which is mature your zero trust model, review and refine access policy every quarter, update the risk models using AML or ML Insight, integrate with Cloud Access Security Broker or CSB, Cloud Access Security Broker and endpoint detection tools. And last is evolve towards a passwordless future across the enterprise. Key milestone? Well, at a strategy and planning phase, it is zero trust blueprint, create that, asset inventory, roadmap. At foundation, you have SSO, MFA, central identity directory setup. At risk based access, you have adaptive policy, risk scoring, session control. At governance, you need to have access reviews, role cleanup, and audit report. And at an expansion level, you need a CIAM rollout, AI, API security, and federated B2B access. SailPoint. SailPoint is a leading identity governance and administration platform that helps organizations control, manage, and audit user access across system, application, and data at scale. It ensures that right people have the right access for the right reason and for the right amount of time. Think of SailPoint as your organization's identity auditor, access manager, and compliance enforcer all in one platform. What SailPoint does? Well, it regularly reviews and approves of who has access to what. User request access and manager approve or deny it via workflow. It helps with that. It helps with creating and managing roles with predefined access rights. It prevents toxic combination, that access to create and approve invoices example. It prevents that. It automatically grants, updates, or revokes access when someone joins, moves, or leaves. It helps provide insight into access risk, outliers, and potential violations. It helps connect with cloud apps, databases, AD, HRMS, and on prem systems. And it helps generate reports for auditors and supports compliance. From a use case perspective, a new employee joins the finance team. SailPoints automatically create their access profile, grants access to finance system based on their roles, notify the manager to review and approve, logs all action for audits, and if they move to HR later, SailPoints revokes old access and gives new permissions instantly. Key components of SailPoints. SailPoints is cloud-based IGA platform, that's identity now. They have on-premise IGA product for large enterprise known as Identity IQ. They suggest access right based on peer analysis and user behavior. It's an AI driven recommendation. It can detect violation and enforce separation of duty policies using their policy engine. They support periodic access review, whether it's quarterly or annually. They have a certification module which does that. It has a self service portal for users to request access to apps or data through the request center. Benefits of SailPoints? Well, it helps enforce least privilege and policy compliances. It helps identify risky access and prevents abuse. It simplifies compliance reporting. It handles thousands of users and apps. And it provides a central view of who has access to what and why. Now, challenges needs, as with any other, it needs clear role definition and policy mapping. It has a complex setup requirement because of integration and workflow can be sophisticated. It requires regular maintenance like regular role review, policy tuning, and access cleanup. Requires end user and reviewer training and need guidance on access certifications. It integrates well with most as with others, whether it's Microsoft or cloud or legacy system or HR systems. SailPoint is the brain of your identity program, governing who gets access, monitoring what they do with it, and ensuring it aligns with the security and compliance policies. Let's look at how access reviews and certification workflow in SailPoint for managers or application owner or compliance team. It starts off by defining the review campaign. What it means, decide which access need to be reviewed and by whom. Who does it? What's the identity governance or IAM admin role? The configuration include review type, who's the manager, application owner or role based. The scope would be all user, high risk role, privileged access, etc. Define your quarterly, biannually or ad hoc requirements. Line managers, reviewers, who are the reviewers, who are the maker, checkers, who are the owners. Once done, you move to step 2, which is generate certification campaign, which means SailPoint collects current access data, entitlements, roles, accounts. It takes the source from cloud apps, on-prem systems, AD, SaaS, whichever is available. SailPoint does prepare a review package, assigns reviewers, and sends notification with due dates. Then, as part of step 3, Reviewers receives the task. Manager or owner logs into SailPoint and see a dashboard of users and their access. They can take decisions like approve, they can revoke, they can delegate, they can comment. Once done, we reach step 4, which is completion of the access review. It means once the reviewer completes the task, SailPoint logs the decision, notifies the IAM system or ticketing tool, and triggers provisioning or deprovisioning workflow for revoked access. Once you do this, we reach step 5, which is remediation and enforcement. Any access marks for revocation is automatically removed via connectors or sent to ServiceNow or Jira for manual action. It's then tracked into the system until resolved. Once done, we reach step 6, which is about maintaining audit trails and certification closure. Means it captures all action, timestamps, and comments. And then it closes the campaign, generates audit ready report for compliance, whether it is SOC, ISO, or GDPR. What are types of certification in SailPoint? We have manager certification where the manager reviews access of their direct reports. You have application owner certification where the app owner validates access to specific system. You have entitlement certification, which is review of specific roles and permissions. You also have event based certification, but triggered by role change, joiner, mover, leaver events. Or you have peer group reviews, where a review based on comparison with similar users. What are the best practice? Well, automate reminders and escalations. Review high risk entitlement more frequently. Ensure SOD violations are flagged during the review. Include training for reviewers to improve quality. And maintain evidence log for every campaign. Let's take a pause here. We have come to end of part 4. We are on track to our agenda. Let's think through, look at the checklist, see which one helps you with your current BAU, with your planning, with your strategies, and you can work on those. If there are aspects that you want but not covered, you can drop a note. You can comment it on the video. Let me just thank you for the time that you have invested till now. We have few more to cover. If you think this has brought value to you, do share it with people who you think can benefit. Do subscribe so that you get notified when a new video is uploaded. Hence, I would like to thank for all the time that you have invested till now. This is your host Savit Vittal Salian. Namaskar. See you in part 5.